Yeah, hi guys. So today I'm going to be talking about kernel density estimation. Okay, some people pronounce it as kernel. Okay, let's just agree with kernel, KDE, kernel density estimation. All right. Normally, when you want to do the data distribution, you will use something like histogram. So let's see an histogram. So I'll just run my libraries. That's import my libraries. That's pandas, seaborn, and matplotlib, and that's it. So I created a list quickly and on the number of gaming hours, not like I play game. Okay, yeah, the number of hours, I play games weekly. Not me or you, because I don't not like I play game as much. All right, so I'm going to run that, and this is it. This is my list. Then I convert it to a data frame, a pandas data frame, because I just love to work with that. I prefer that. So straight to the point. So if I create an histogram, this is what we generally use to check the distribution of our data sets. Okay. But why do we now why should we prefer KDE over histogram? And it is because it provides a smooth and continuous curve that accurately represent the underlying data distribution without the need for arbitrary binning, because there are some arbitrary binnings in histogram. Okay, and one of the things that the smoothness in KDE does is that it reduces the influence of noise and allows for better visualization. And we're going to see it by the time I plot it. It allows for better visualization because it is really flexible. KDE is flexible, and it accommodates both small and large data sets by enabling interpolation and extrapolation of the data by and also offering insights that is beyond the observed data range. And that is what you're going to see. You have insight that is beyond the observed data range. So I'm going to run the KDE plot now for you to see it. So this is the KDE plot. But through this now, you may not be able to quickly understand what is going on here, and that is why there's another thing that we have to the function that will help you to uh, understand it better, and that is the bandwidth. So this is the smoothness. You can see the smooth curve. So by the time we adjust the bandwidth, because the data set is not very large, so I use a low bandwidth. If it is very large, you can increase the bandwidth. So this is the bandwidth method. You add the method to the KD plot function, and when I run it with this, you could see this now. So by looking at this now, you could see that between 5, 6, and 7. So the highest hour that I play game or from this data set, there are 5 hours, 7 hours, and 6 hours. And those are the times. So I could easily see things by even adjusting the bandwidth. So if I increase this, you could see that it came back to something like this. If I change it to zero point 0.1, I mean, it's going to be very small. So I prefer zero point 0.2. So you can see that this now is offering an insight that is beyond the observed data range compared to histogram that it just looks like, some blocks that way. It is not so interesting to visualize like you will have with the KDE. So that is it shortly. So just try out KDE and let me know what you find. If you find it interesting, it will be really be good. And there are other things that you can get from KDE. So I'm going to attach a link to where you can read about the kernel density estimation so that you can learn better about it. And also a link to the Seaborn, the KDE plot function. All right. So enjoy yourself. Thank you.